dedicated to a mission larger than our lives. Spiraling use of oceans for economic gains has plunged the world into a pandemonium. Increasing cannibalism of periphery makes our hawk-eyed vigil ad rem. Changing face of conflict at sea. Citizenry blinded by their own incentives. We manage all conflicts constructively. Brothers on my left and sisters on my right. Together we stand. Together we guard. No task too great, no dream too grand. With our planet's alarm going off, the urgent threat facing our entire species, our responsibility knows no bounds. For we are the guardians of sustainable tomorrow. Hours, weeks, months and years, we never fail to prepare. Amidst growing challenges at sea and threat to economic zones, we are always on standby to stand by. With over 96% of Earth's water seabound, we enforce our nation's law at sea. From nature's fury to man's deceit, we stand guard against all.
18 Sergeant Central.
Seven seas and 5 oceans. We have eyes far and wide. We are the Indian Coast Guard. Saviors at sea. We are Yatra, Tatra, Sarvatra.
Ladies and gentlemen, since its foundation in 1977, the Indian Coast Guard has been actively involved in defending our nation's maritime interests. Indian Coast Guard has proved its mettle time and again as an important and efficient tool for maritime diplomacy in the region. Today, Indian Coast Guard is synonymous to a leading Coast Guard in the Indian Ocean region, with an exemplary track record in maritime law enforcement, maritime search and rescue, medical evacuations at sea, and marine pollution response, both nationally and internationally.
1978 में भारतीय तटरक्षक की स्थापना केवल 2 फ्रिगेट तथा गश्त के लिए 5 नौकाओं से की गई थी। और ये बताते हुए मुझे गर्व है कि पिछले 4.5 दशकों में स्वप्रेरित एवं समर्पित अधिकारियों तथा कर्मचारियों के कर्मठ प्रयासों की बदौलत आज भारतीय तटरक्षक के बेड़े में 200 से भी अधिक छोटे बड़े पोत तथा 75 वायुयान हैं।
We would like the audience to know more about the Indian Coast Guard with the next video clip which we have.
"2020, a year that started like any other. Like always, we stared the challenge in the eye and met the trouble squarely. Our imagination caught by the sound of waves, we discharged our duties bravely. The world was spinning as always. The sun rose, but the time stood still. In the face of calamity, we battled to defend everyone's right to live. We held hands and ensured safe passage with minimal restrictions, but didn't let our guard down. We stand guard over the development, the security and safety of our nation front and center in our minds. The sea blood brimming in our veins, we embrace this shoreless ocean as our workspace. Fire and storm, we have faced it all, undeterred and undaunted. We don't aspire to be heroes. We are one. Protector of the unprotected, unrestrained like the sea, we can turn calm to stormy. We pride ourselves in recognizing the warrior in others. It takes a warrior to know a warrior. We wear this uniform with pride and honor. Thunder rolling on the far-off horizon cannot deter us. We cannot live in landlocked harbor. Our duty is guarding our denizens. Our excellence is not an accident. It is the result of high intention, sincere effort, and intelligent direction.
Ladies and gentlemen, we would now like to call upon the speakers for today onto the stage. We would request them to join us on stage now.
Ladies and gentlemen, we'd like to welcome our eminent speakers for the day. Ladies and gentlemen, we are now awaiting the arrival of Additional Director General K.R. Suresh, President's Tatrakshak Medal, Coast Guard Commander, Western Seaboard.
We would once again like to request the audience to switch off their mobile phones or keep them in silent mode. Ladies and gentlemen, we welcome amidst us Additional Director General K.R. Suresh, President's Tatrakshak Medal, Coast Guard Commander, Western Seaboard. जलम जल स्थान गतिम सर्वथा एव रक्षणीयम जनुतु ना सुख जीवनम हेतु जलस्य रक्षणम नूनम भवतु. The adage in Sanskrit, which we seen earlier, it means water and all water bodies are to be constantly protected. For the well-being of all life forms, the protection of water is of utmost importance. The Sanskrit shlok elucidates unequivocally the importance of the task at hand, the protection of our nation's waters.
Good morning, ladies and gentlemen. On behalf of the Indian Coast Guard, we would like to extend a very warm welcome to this august gathering of the officials from the armed forces, dignitaries from various organizations, and We would be commencing the seminar with a keynote address, following which we have a series of informative presentations by our highly experienced speakers, followed by a panel discussion. We would like to apprise the audience that the house will be open for a Q&A session after the panel discussion, and hence the audience is requested to reserve their questions until then. Post the felicitation ceremony, we will be culminating the seminar with a group photography and distribution of memorable souvenirs to all attendees.
With this seminar, we hope to provide our eclectic audience an excellent opportunity to interact with domain experts and receive valuable insights on emerging trends in the field. We also take this opportunity to welcome our friends in the media. Moving forward, a keynote address will now be delivered by Additional Director General K.R. Suresh, President's Tat Rakshak Medal, Coast Guard Commander, Western Seaboard. The flag officer joined the Indian Coast Guard on 19 January 1987. On elevation to the rank of Additional Director General, he took over the command of the Western Seaboard. During his illustrious career of 35 years, he has commanded various units, both ashore and afloat, and held key staff appointments. The officer is a specialist in communication and electronic warfare. He is an alumni of the prestigious National Defense College, New Delhi, College of Naval Warfare, Karanja, and Defense Services Staff College, Wellington. The flag officer is a recipient of the prestigious President's Tat Rakshak Medal, Director General Indian Coast Guard Commendation for Meritorious Services, and Special Operations Badge. I would now like to request Coast Guard Commander, Western Seaboard, to kindly deliver the keynote address.
Vande Mataram. ADG S. Parmesh, Commander, Coast Guard, Eastern Seaboard, respected dignitaries, elite audience, ladies, gentlemen, friends of the media, good morning to all of you. It's indeed a great honor and privilege to deliver the keynote address on a very relevant and futuristic subject of advancement in maritime surveillance system and assets, a key to optimized operations at sea on the sidelines of the prestigious Aero India show. In the next 15 minutes or so, I will touch upon as to how in the overall national interest we can move towards triple E of operations, that is economy, efficiency, and effective operations, tapping the potential of technology in maritime surveillance systems and assets. Economy in operations is prudent since the funds get diverted for overall development of our beloved nation. Some of the greatest challenges the world faces today strategically includes poverty, population explosion, clean water, food, safety, and protection of human life and islands, climate change, energy, and resource crunch. A realization has come to fore that oceans possess the key to majority of our problems. It is no coincidence, therefore, that throughout the history, mankind has turned towards oceans for solutions and resources. The maritime domain has been a crucial space in investment of emerging powers, shaping regional dynamics and the larger security architecture. The Indian Ocean has emerged as a critical conduit for trade, commerce, and energy. The region contains 1/3 of the world's population, 25% of its landmass, 40% of world's oil and gas reserves. It is a locus of important international sea lines of communication, These choke points in IOR are the immense strategic importance as huge volumes of trade pass through them, and these are exposed to piracy, international disputes, political dissents, and accidents. On the other hand, the region is also central to many natural disasters, international terrorism, human trafficking, transnational organized crimes, contraband smuggling, and other oceanic challenges. India's pivotal position in the Indian Ocean region gives her overarching advantage and at the same time presents far greater challenges. The Indian Ocean basin is of particular importance for India as the region's most populous country, having strong historical influence on littorals, a geopolitical keystone, and upholder of democratic values. Considering the growing need for maritime cooperation and security, our Honorable Prime Minister gave the mantra of Sagar, which stands for security and growth for all in the region. Ladies and gentlemen, there are around 160 countries around the globe with coast guards or similar agencies. These coast guards or maritime agencies fulfill obligations carved out of United Nations Convention on Law of the Seas and various conventions to maintain good order, peace, security of oceans, safety of mariners, coordinate measures for protection of marine environment, and equitable sharing of resources. During peacetime, these coast guards with non-belligerent, non-escalatory, non-aggressive, and overt disposition are connected with each other towards larger service to the humanity in the form of ocean governance by ensuring safe, secure, and clean seas. The Indian Coast Guard has emerged as the key maritime law enforcing agency of India, responsible for implementing national and international obligations related to maritime safety, law enforcement, and marine pollution, with a leading role in facilitating maritime activities and trade. Indian Coast Guard Maritime Rescue Coordination Centers, that is MRCCs, are connected with MRCCs and information centers around the globe through the mandate of Global SAR Construct, anti-piracy regimes, marine environmental protection initiatives, besides other maritime frameworks for responding to peacetime maritime challenges. Over the last 4 decades, our regular SAR communication exercises, training programs, operational level interactions, national level exercises in maritime search and rescue, and pollution response with national and international stakeholders have enabled strong diplomatic relations and strengthened the oceanic peacetime reliability factor. Indian Coast Guard has earned the recognition as the leading professional and responsive Coast Guard agency in the region, thus complementing India's rise as a major maritime peninsular nation. The impeccable professional record, benign disposition, and humanitarian peacetime charter places Indian Coast Guard as the preferred tool of maritime diplomacy and coordination. Indian Coast Guard is uniquely placed in the context of international cooperation and is poised to play a pivotal role in realizing the vision of Sagar. Maritime surveillance systems and assets are core to Indian Coast Guard Charter and therefore play an instrumental role in achieving aims of Sagar and sustaining India's leadership in responding to maritime challenges of the regions. The Indian Ocean region faces particular challenges in detection of an anomaly during surveillance efforts. The sheer number of merchant, fishing, and air traffic coupled with loosely regulated regimes, poses a formidable challenge in terms of magnitude of efforts. These numbers are only going to increase as we are aware. Operations, their sustenance and maintenance of surveillance assets is an exorbitant challenge, especially when they are other than Indian origin. Even slightest of disturbances in global supply chain, local factors, and interdependent diplomatic relations proliferate, stalling availability of critical equipment and spares. Considering these prerogatives, as well as to improve economy and utilize the Indian human potential to its best, our Honorable Prime Minister gave a clarion call on Atmanirbhar. Taking a cue, Honorable Defence Minister, Defence Secretary, and his entire team has progressed in a mission mode with relentless efforts to achieve self-reliance and provide a momentum to much-needed defense production. As per a report by Stockholm International Peace Research Institute, SIPRI, though India's total volume of defense imports fell by 21% from 2012 to 16, which could be a reflection of the push to indigenous manufacturing. However, India still remained the largest importer, accounting for 11% of global arms imports during the year 2017 to 21. Indian Coast Guard has been a pioneer in Atmanirbhar drive, and thanks to the Ministry of Defence, shipyards, and Hindustan Aeronautics Limited. Our ships, Dornier aircraft, and advanced light helicopters are all indigenous. With the recent induction of aerial drones, the service is on track for modernization. However, there are many miles to cover, and it's a work in progress. With the changing technology, environment, and systemic variations around us, we need to match the pace. We can ill afford to employ public money behind obsolete assets and systems, which derive little benefits. Coming to maritime surveillance systems and assets, it's a complete ecosystem in itself. The advancement includes surveillance aircraft, satellites-based systems, unmanned aerial and surface vehicles, chain of static sensors, and integrated automatic identification systems. Integrating metadata analytics, artificial intelligence, and machine learning in the surveillance processes would be the future. Indian space agencies have made great strides in space sector. However, peacetime surveillance efforts are yet to reap benefits from the advancements. Real-time or near real-time imageries or sensors, vessels and analytics have the potential to optimize our operations. Satellites with appropriate payloads and data links with high-resolution cameras, radar, and communication sensors will be a force multiplier which can be used in searching distressed fishing boats, tracing suspicious crafts with narcotics or human trafficking, as well as provide early warning of impending weather or security-related threats. Our offshore areas with vital installations can be particularly benefited with UAVs and underwater unmanned vehicles with endurance, which can provide real-time information to monitor illegal activities, search bodies, and assist tracking vessels of interests. Artificial intelligence and machine learning techniques will not only improve the efficiency of maritime surveillance, but also enhance effectiveness and economy of our endeavors. Some of the immediate challenges to these advancements seems to be integration of surface, underwater, aerial, and land-based surveillance networks on a common grid, ability to search, detect, classify, identify, and report all contacts for possible threats, their recording, tracking, communicating, and responding quantify the other part of the puzzle given the global nature of shipping, incidents in maritime domain which proliferate quickly from various legal, humanitarian issues to security issues. With emergence of open registries, non-state actors and rogue states in Indian Ocean region, the future demands a seamless surveillance. Advent of unmanned surface, underwater and aerial vehicles and their possession with rogue elements have posed additional challenges for detection and response. Our quest towards Sustainable Development Goal 1.4, energy resources at extended ranges and endeavors for safety of mariners and fishermen will be challenged by recurrent weather disturbances and climate change, stretching our existing resources and their capabilities to limits unless we evolve. It won't be incorrect if I say that I have started, but we have also started. Our work towards Atmanirbhar has to cover a large ground. As a nation, as we are aiming to derive benefits of blue economy from far-fetched islands, it is equally important that our infrastructure and maintenance capabilities for surveillance should match the commercial aims, including augmenting remote aircraft and UAV operating bases from small islands, helipads, and emergency landing bases on vulnerable islands. Our aviation support industry, in particular, has an instrumental role to play, starting from in-house production of surveillance systems and their spares, including product support. The industry ecosystem should be able to provide products and maintenance to reduce downtime so that operational availability and operations are sustained. Besides the IT industry, new startups, academicians, R&D construct will have to develop in-house artificial intelligence-based integrated processes and tools to integrate metadata from surveillance tracking systems. The world has witnessed crippling down of stock markets, chain of hospitals, banks, and defense institutes due to regular cyber attacks. Maritime surveillance systems is no longer immune to these threats. Cyber security and our abilities to protect our assets and systems will be an important skill set towards our sustenance. Skill development will be an inescapable need to attune our forces and support teams. We may have to share our recruitment or engage with vertical specialists to create a holistic capacity building to support our surveillance construct. In order to optimize our operations at sea, we may have to look for dual-use technologies for both security and civilian agencies. A large number of solutions and machineries provide avenues for dual-use, collective production, and capacity building of such products, automation and processes that are made in India and made for India will have far-reaching strategic consequences. Automation that reduces reliance on mechanical and engineering crew and increases prediction and prescription capabilities of computer programs instead of human knowledge are vital. This is not just the matter of having more sensors, but improving information technology, analysis, and decision-making based on significantly richer data, predictive analysis, and behavioral models with data analytics provide opportunity to anticipate the possible threats. If I take you out for an eagle's eye view for effective and efficient ocean governance, my demands, or rather wish, would be a combination of inputs derived from technology, fusion of ocean data, coastal and onshore surveillance measures, supported by maritime domain awareness tools, human intelligence, wherever feasible, and integrated with stakeholders' support. Fusion of the inputs through the integration of human int, technical int, and physical surveillance measures can produce optimal efforts and better decision-making solutions. Availability of friendly assets beyond ISRR or our area of responsibilities through cooperation and collaboration would provide strength and confidence in operations. Terrain mapping, and in particular human mapping, as being done by land forces in maritime domain, though challenging, is achievable by building networks and integration with stakeholders. It would help us in plugging gaps in maritime surveillance. In sum, in our quest towards optimized operations at sea and realization of the aims of Sagar, we will have to plug the lag between availability of technology in the world and that with the surveillance agencies. Some of these challenges can be addressed with technology, whereas others will require innovation, integration, manufacturing with new concepts, skill development, institutional frameworks, collaboration, and perhaps new policy regimes. The future of maritime surveillance assets and systems will be characterized by increased use of real-time technology, automation, satellite-based and unmanned vehicles, integration of enhanced effectiveness and efficiency of our operations. Cooperation and collaboration will play an instrumental role in economics and optimizing operations. Having a friendly asset on edges of ISRR or AOR would generate confidence and strength to our operations. The mantra of Vasudhaiva Kudumbakam is imperative for the realization of global good, preserving common heritage of mankind, and tackling maritime challenges, which is the need of the hour for optimizing ocean governance in the peacetime. I would leave the audience with a quote from our Honorable Prime Minister, Shri Narendra Modi, that, quote, "Our ability to reap economic benefits from the oceans rests on our capacity to respond to the challenges in the maritime domain," unquote. Gentlemen, I have finished. Jai Hind and Vayam Rakshama. Thank you.
Thank you, sir. Your words have added a valuable dimension to our event, and we are sure that it will continue to influence and guide us in future. Ladies and gentlemen, we would now commence our presentation session. Our first speaker, Mr. S. Padmakumar, is the Managing Director of Engrav Aviation Services and Systems. He has 37 years of experience across maritime, aerospace, defense, and civil aviation domains. He has worked for 3 different passenger and cargo airlines operating internationally. For his contributions in the aircraft design and development program, Mr. Padmakumar was awarded the coveted Meritorious Service Award by the Honorable President of India.
With rapid advances in automation significantly reducing the human workload, artificial intelligence is a theme which finds substantial mention in discussions pertaining to military requirements. In line with the theme, for today's first presentation, Mr. Padmakumar would be familiarizing us with how the adoption of emerging technologies like artificial intelligence and machine learning would impact the domain of maritime surveillances. Also, coming back to the Coast Guard after 16 years, being a Coast Guard veteran, so it gives me immense pleasure to invite Mr. Padmakumar to deliver the presentation.
Good morning, everyone. Thank you for joining me today. I thank Indian Coast Guard for giving this opportunity to talk. The praiseworthy role Indian Coast Guard has been playing day in and day out to protect our maritime interest. It needs a special mention. I'll be talking today on a solution-centric approach for preemptive maritime surveillance by leveraging on emerging technologies. The current focus of the maritime surveillance is to see what's out there, detection, what is it doing, the tracking, and the identification. There are numerous technologies, significant technology advances have already been made. So many onboard sensors, radars, electro-optical and infrared sensors, unmanned aerial vehicles, unmanned underwater autonomous systems, all are in there to collect this, to do this detection and tracking. Satellite technologies have enhanced the tracking and detection capabilities further. The challenges comes next. Can anything and everything at sea be detected? Most of these sensors which I just mentioned, except the long-range identification and tracking systems and the satellites, there are tendencies where small-sized boats could move undetected. For the identification, we have the automated identification systems, but can be manipulated to provide false information if a perpetrator really want to play mischief. And they can either switch off or they can spoof it. Now, this leads to the decision conundrum for the Coast Guard commanders, what to do. Even if it is detected and tracked, does it reveal the real intent of the perpetrator? Even if the intent is understood, what should be the response strategy? And unless the intent is known of a contact designated as a suspicious contact, the response strategy will remain a gray area. Should it be a reactive response? Should it be a proactive response? Should it be a deterrent response? Should it be an introduction? So this is an analysis which currently happens in the human brain. And the large volume of operational data will have a tendency to clutter the decision making. So what should be so that plays the availability of sea assets and the air assets for the response, the serviceability, the capability of the assets, the sea assets and the air assets, their limitations, their availability, serviceability of each sea assets and air assets, their current location, the deployment and redeployment plans as per the need. While in the operational mode, the operational disruptions due to unserviceability of these assets, the sustainment support, all this creates the whole maritime ecosystem, a very complex scenario to handle. So what should be the way forward? This is a slide which depicts. You have the sea assets at sea, the air assets, their onboard sensors, the assets operational data, the maintenance data, the logistics data, all are there. The assets are at the scene of action. And the onboard sensors keep acquiring this data on a continuous basis. Now, if the satellite data obviously will validate, it can collate, interpret, and this data which is acquired by the onboard sensors can be validated further. If this is the challenge is the human analysis of this dynamically changing data as per the dynamically changing scenario at sea. So there comes the emerging technologies. And if this data can be brought in, and the different machine learning algorithms and the AI engines can be developed, the analytics part of it can be taken care of by the AI engines. It can be descriptive, means what is happening right now, diagnostic, why it is happening, predictive, if the situation remains so, what it is going to happen, prescriptive, what should be done to deal with it, what is the need of the hour. So there comes the assets at the core of the maritime surveillance ecosystem. We have all the sea assets and the air assets. They are the first responders. They are the people on scene. The onboard sensors gather a lot of intelligence, data intelligence. And whether it's a transactional information while during a mission, or it could be due to maybe innocent data acquired from innocent looking contacts. Whether the Coast Guard sea assets or the air assets, while on routine patrols, routine reconnaissance missions, the data acquired can bring in, if analyzed well, can bring in a lot of valuable trends, insights, and even actionable inferences. And that cannot be done human, and that's where the emerging technologies come in. So it has to be an integrated approach. It has to be a sea asset and air assets, the onboard sensors, even the satellite coming in. So the phase one is to have the data. Without the data of surveillance data, there's no analysis possible. So phase one could be the induction of all the sea assets and air assets into one system, which can deal with operations, maintenance, and logistics information of the Indian Coast Guard. Once done, the data is available. Then comes the use cases for maritime surveillance is one use case. Coast Guard must be having many other use cases. Maritime SAR, law enforcement at sea, pollution response at sea, predictive maintenance, sustainment support, it goes on. And with this data being available and the use cases being built in, with the indigenous development, indigenous technologies are available to create the AI engines and machine learning algorithms. This is there. This technology is available. And both this phase one, it is already there. Made in India solutions are available, ready to be deployed. Phase two is the development of these engines. And the ISRO's Navik constellation of satellites is already in the orbit. Satellite technologies can enhance the detection and tracking capabilities. So what all put together, what you have is a comprehensive sea plot and an air plot, even extended further a land plot, if the land assets are indexed. So this is probably a way forward for a futuristic maritime, a preemptive maritime response, a transformation from a reactive maritime surveillance operational doctrine to a preemptive surveillance operational doctrine would need an integrated bottom-up and holistic approach. When I say bottom-up, I mean the assets have to get in first, then only the data access happen. Thank you very much. Thank you for the time and attention. I look forward for any questions during the question and answer hour. Thank you very much.
Thank you, sir. Your wealth of knowledge and expertise on the subject is truly impressive. Moving on to our next distinguished speaker, Dr. S.K. Venkatesh, Scientist G, is the Group Director at the Center for Airborne Systems, DRDO, Bangalore. He is heading the much heard of AAMA program, that is the Multi-Mission Maritime Aircraft for the Indian Coast Guard and Medium Range Maritime Reconnaissance Aircraft for the Indian Navy. He was responsible for the design, development, integration, and testing of the complete electrical systems of the airborne early warning and control aircraft Netra, which has been delivered to the Indian Air Force.
With increase in geopolitical volatility surrounding the Indian subcontinent, coupled with the burgeoning economic prowess of our country, the requirement to augment reconnaissance capabilities in the maritime domain is ever increasing. On this note, I would like to invite Dr. S.K. Venkatesh to familiarize the audience with the AAMA project.
Thank you very much for the introduction, and good morning to you all. Here I see a wide spread or mix of audience. In the front rows, we have professionals who know their job or well informed, but at the rear, I see some young students. Somehow I tuned my presentation to the well informed, and nevertheless, I tried to make it more meaningful for the students also. So I'll be presenting what are the development activities which carried out at Center for Airborne Systems towards the maritime multi-mission aircraft for the Indian Coast Guard. So this is how I planned my presentation. I just give a brief background of the MMA program for the Coast Guard. And now this Coast Guard is pursuing this program for quite some time. Meanwhile, DRDO has taken up a project called Lead-In Project, and we acronymed as an ASA-based integrated sensor suite, wherein we can develop the sensors, and later on it can be adapted to MMA whenever it is sanctioned. And finally, a slide on conclusions. So why CAPS? What is the pedigree of CAPS? So that you can take up this. We have all the expertise and infrastructure developed over the years in airborne systems and surveillance technologies. We have learned a lot of lessons, and we have to exploit it and make it this system very successful. And we have successfully delivered the airborne early warning and control system. You can see it is flanked by so many other aircraft. It's one of the complex system, and it has been used extensively by our Indian Air Force along the borders. So this is maritime multi-mission aircraft for the Indian Coast Guard. Its primary roles are maritime surveillance and interdiction, search and rescue, and pollution surveillance. It has got secondary roles also, sort of role conversion. Quickly, we can do some changes so that it can be used for cargo and personal transportation as well as an air ambulance. So as I said earlier, Coast Guard has been pursuing this for quite some time, for a decade or so. But finally, the government said, let us finalize the aircraft. That aircraft deal was also going on. Now, you know, recently, the aircraft deal between Tatas and Airbus has concluded. In that, the aircraft identified is C295. That meets more or less all the requirements of the Coast Guard. And the OEM is Airbus Defence and Space. And 56 aircraft has been ordered by IF. 40 will be manufactured in India by Tussle. And the remaining 16 aircraft will fly away. Now, in addition to that, Coast Guard as proposal is for a 6 MMA aircraft. So this aircraft, green aircraft, has to be converted to a blue aircraft. In the sense, it has to have some conversion so that we can put in all our systems. That conversion, we propose to do 2 from ADS because they have all the design data of the aircraft, and they transfer the modified kit to Tussle so that other 4 can be manufactured here in India towards Atmanirbhar programs. So we have almost, DAC clearance is almost, we are able to get it, but in the meantime, Navy intervened. They also wanted this program, the same aircraft for their MRMR product, medium range multi-recurrence aircraft. And we are also working on both these projects simultaneously. And most probably the clearance will be obtained as a single program for both Coast Guard and the Navy. So this is about multi-mission maritime aircraft. So we have IFF integration. I got a pointer? No, so we have got IFF. In the front, you can see EO electro-optic infrared sensor that is for imaging, both in the visual and the infrared ranges. And we have the pollution surveillance equipment, and we have the maritime surveillance patrol radar. Of course, AS is there. And we know the roles of this aircraft, and that's how the picture comes with the integrated operation of all these sensors together. And we have all the ground station. So, pending the sanction of MMA, a leading project was launched by DRDO. So it's a technology demonstrator. The cost is there, 67 crores. The project duration. So we've been working for quite some time. And in fact, in our midst, we have Dr. Reena Sharma. She was the project director for this program. So we have successfully designed, developed, and integrated these critical systems that goes into an MMA. That is ASA radar, so pollution sensor set. Pointer is there. Thank you. We have integrated most of the critical sensors that go into MMA, and it has been proven in the lab. So we have followed the system engineering principles. We are not limited to what the project has. We have developed all the architectures, all the ICDs, SWAP, so that this information can be given to the aircraft manufacturer so that the aircraft can be modified to fit in all the MMA systems. In fact, what is grown in green is brought-out systems. PSS is a brought-out system from Optimer, AS from CNS. The remaining things we have developed and successfully integrated and proven in the lab. So we have followed system engineering principles, and in fact, we have designed all the layout, including the internals. On the top figures shows all the externals, sorry. You know, it's skipped. And we have, these are the systems developed, integrated, and tested under Abyss project. So we have the ACM Maritime Petrol Radar housed in a, go back one slide, huh? How to go back? Okay. Yeah. So we have everything ready. Once the program is sanctioned, we can directly float the RFP for the Airbus OEM to incorporate all these modifications. That's the advantage of having a leading project. So we are geared up to launch the MMA program. So under this Abyss project, what are the systems they are developed? That is AAC MPR, housed in aerodrome. Then we have got electro-optic IR sensor, and this is the pollution sensor suite, AI systems, the multifunctional tactical console. The heart of the system is mission management system. All this can be integrated and have a cogent operation, and command and control, everything will be done through this. The detailed software has been developed, and all, it has been successfully integrated and tested as all the systems together. You can see that was about Abyss architecture. Now, just by addition of IFF CBTL, the C-band data link, and the satellite data link, and the mission communication systems, which we have already proven under AWC program, the MMA program will be complete. And we also finalized the architecture of the MMA. So everything is ready on paper on MMA. We can just kickstart once the program is started. So now I'll go into what are the systems developed. I'll not take much time. These are the specifications. We have followed the Coast Guard staff qualitative requirements. From that, we have derived the specifications of the individual systems. You can just go through it. It has got all the MPR modes. And what is the advances from the conventional radars? I'll come to a bit later. And these are the modes of operation. In fact, we have studied the various radar configurations. Unlike the older radars where the antenna rotates, this is electronically scanned. There is no rotating element. We have studied for 360-degree coverage, 3 antennas, 4 antennas. In fact, we've done a lot of studies to arrive at an optimum solution. In fact, we have this already set up in the lab. You can see this is the antenna. It radiates through this exciter, and the receiving signals we have, it's a digital radar. You can call it as a digital radar to get a good radar picture. In fact, we have tested in the lab all this the integrated condition. So it's called a digital radar over IP architecture. Now I'll just reel out some of the advanced features of this. Maybe after the question and answer sessions, we have got some radar experts there. I'm no radar expert. You can have more meaningful discussion with them. That's it. So in fact, a lot of simulations have been done for advanced sea clutter studies. Simulation has been done. Advanced radar detection using Kalman filtering, that has been done. Digital monopulsing for correct azimuth angle prediction. The adaptive digital bomb firing, anti-jamming capabilities. All these features have been tested and incorporated in our hardware, including small target detection in clutter. So now that is about the radar. Now coming to the pollution sensor suite. These are some of the introduction things. I'll just go to the next slide. These are the sensors. These sensors were brought out from where, but all this has been integrated along with all other sensors, and we have the command and control. So we have the side-looking airborne radar for detection of surface films. We have IR and UV. These are the standard things for relating thickness. You can just go through it. In fact, this is also set up in the lab, and we have to test in the lab. We have got different types of oil samples of different thickness. We can test the system. You can see the SLAR antenna mounted on the rooftop, and we have the full setup wherein the entire pollution sensor suite as an integrated, where all the sensors operate together. That can be tested and calibrated also. Now coming to the infrared optical red systems, we have these different sensors. In fact, this has been developed in-house. The sensors are brought out, but they have been packaged with stabilized gimbal platform. Everything has been done in-house. And in fact, there is a transfer of technology for the private manufacturer to produce the numbers. This is how typical installation is there. These are the sensors. And that is all been integrated in the lab setup. Now, in this, we can see here, these are the sensors. And we have an AI hardware, and that gives you the output. A lot of algorithms have been developed using artificial intelligence. One is automatic target detection. Just by sensing, it can tell what is the object. And we have done AI-based image and video fusion. Here you can see this, probably this building is not visible because of some haze, whereas in infrared it shows up. When you combine both these images, this building is also there. So you get the best of both these, and using AI you can combine the features. So this also has been tested. The AS to AS interaction has been set up. You can see AS antenna, and there is a transponder. So the complete systems have been tested, and it is integrated with the software. I think I'm running out of time. I'll just quickly wind it up. And in fact, this has been combined to the end user, so that on the display, we can see the operation command and control and the output of all the sensors. Sorry, I think some more animation is creeped in. I was not noticed, sorry for that. I will just quickly go through it. And in addition to that, we have used multi-sensor data fusion, where a cogent picture with the input from all the sensors, we get one single picture. That will be very useful, instead of an operator trying to decipher and see what is it. I just see, sorry for that. Just some of the schemes. In fact, the entire architecture also is complete. We have, in addition to that, we have developed the HMI as per the Coast Guard requirements and standard requirements. And this is the final integration scheme where all the sensors are integrated. It is an open architecture. Any other systems can be easily plugged in. And in earlier program, we have got some other systems like IFF, C-band data link. All this can be plugged in and form a complete MMA. Some of the conclusions you can see. Geared up for launching the MMA, we are ready. The moment the program is sanctioned, we can immediately launch it. And critical technologies and subsystems for the MMA have already been proven, and we have the latest MSDF and AI algorithms to get a better picture. Some of the other conclusions are there. Thank you very much. Sorry for just running out of time. Thank you.
Thank you, sir. With the AAA project having gained quite a lot of traction of late, I'm sure the information has brought to the fore immense value. Our next speaker, Commandant A.R. Kalingal, joined Indian Coast Guard in 2004. The officer is a qualified flying instructor and has clocked more than 5,000 hours of flying. He has completed the Search and Rescue Planning course from U.S. Coast Guard Training Center, Yorktown, Virginia, in the year 2016, and the Human Factor and Accident Investigation course from Institute of Aerospace Safety, Delhi. The officer has also completed a leadership course at the Indian Institute of Management, Kolkata. He has been awarded the Director General Indian Coast Guard Commendation twice for his dedication towards service.
In-depth understanding of any topic requires extensive research coupled with a vast empirical experience. Keeping that in mind, we would like to invite Commandant A.R. Kalingal to kindly share with us his analysis on the present and future trends of maritime surveillance equipments.
Good morning, ladies and gentlemen. It's indeed an honor for me to present before you the topic, maritime surveillance assets, present and way ahead. In the next 10 minutes, I'll be covering you through these aspects. Maritime surveillance equipment and assets are a vital component of ensuring maritime safety and security. They include a wide range of tools and technologies used to detect, track, and identify ships and other vessels, as well as other activities in the maritime domain. These tools include radar systems, AIS, and satellite imagery. They are used by a variety of organizations and agencies involved in maritime surveillance and security, including Coast Guard, navies, and port authorities, to monitor activity in coastal waters and EEZ. It shows a broad outline of the present maritime surveillance equipment. They are maritime patrol aircraft, patrol ship, coastal radars, satellite surveillance, VHR, very high resolution optical monitoring, LRIT, and shore station. It gives a complete picture of the scenario from various agencies to be analyzed and action taken upon. ISR, the intelligence, surveillance, and reconnaissance, is a set of activities and capabilities used to gather and analyze information about an adversary or environment. RMP is a comprehensive and up-to-date understanding of the maritime environment, including the location and identity of all vessels and objects in a given area. An RMP can be used to monitor shipping traffic, plan search and rescue, and respond to environmental incidents such as oil spills. To carry out ISR and RMP, we have sensors. Basically, there are two types of sensors. They are passive sensors that detect and gather information without emitting signals or energy. They can be used to detect ships at a distance, even in bad weather conditions, and to track movements over time. They include tools such as acoustic sensors, optical sensors, and infrared cameras. Satellite imagery, maritime surveillance systems use satellite imagery to monitor and track ships and other vessels in the ocean. The system typically involves the use of high-resolution satellite imagery, which is analyzed using specialized software to identify and track ships. We have AIS, a system used by ships and vessels to automatically transmit their identification and location information to other ships and to shore-based stations. Information is typically sent via a VHF radio frequency. Thereafter, we have active sensors that emit energy or signals to detect or gather information. They include ARP, high-frequency surface wave radars, and skywave radars. Having known about sensors, we come to the present sensors in the Indian Coast Guard. We have the MSS, the Maritime Surveillance System. It was originally developed for environmental protection, oil spill detection, mapping, monitoring, and documentation. Users have found that MSS is extremely useful for monitoring activities on the sea surface. Here you can see the SLAR antenna that has been kept on one of the Coast Guard down here for the carrying out MSS. The SLAR, that is the side-looking airborne radar, is mainly used for the surveillance of large sea surface areas, making it possible to detect oil slicks and other targets. The SLAR is a radar without moving parts. Its design has been optimized for detection of oil spills at sea. The SLAR is equally effective for the detection of small point targets, example, small vessels and man overboard or life rafts. Thereafter, we have FLIR. FLIR is a type of imaging technology that uses infrared radiation to create images. The FLIR cameras can detect and measure the heat emitted by objects, which allows them to create images of objects in low light or complete darkness. Indian Coast Guard aircrafts, namely Dornier 228 and ALH, are mounted with FLIR for maritime surveillance to detect and track ships and other vessels in the ocean. It can also detect oil spills, locate survivors in the water, and locate objects in the water, mines or lost containers. We have ELTA radar. The Maritime Radar MPR is a multimode X-band coherent radar that supports both air-to-sea and air-to-air mission, designed to detect both small targets at long range and high sea states. Both Dornier 228 and ALH Mark III are fitted with ELTA radar in Indian Coast Guard. They are utilized in various maritime operations such as maritime surveillance and long-range EEZ patrol, SAR location and support, law enforcement, fisheries protection and enforcement, supports air-to-sea and air-to-air missions, detects small targets at long ranges. Known about the present systems available with Indian Coast Guard, I'll be now talking about what sensors are available with the other countries or how they have amalgamated the sensors. First, we have the CISC. It's a European Union initiative which aims to make European Union member states surveillance system to interoperable to give all concerned authorities from different sectors to access to additional classified and unclassified information they need to conduct missions at sea. The goal of CISC is to improve the efficiency and effectiveness of integration of existing surveillance system. The advantages allows organization to have all existing tracking system to share information real time and provide single point of access to a wide range of information such as AIS, radar data, and satellite imagery, allows organization to have a more complete picture of maritime activity and to identify potential threats more quickly. Thereafter, we have LRIT, that is a long-range identification and tracking system. It is designated in the IMO system designed to collect and disseminate vessel position, information received from IMO member states and ships. The LRIT system provides global real-time information on the position, speed, and course of the ships in the maritime domain. The system is a maritime surveillance system based on the AIS. It extends the range of AIS by using satellite communication to transmit and receive information. With LRIT, ships and vessels can exchange identification and location information, not only via VHF frequency, but also via satellite and terrestrial communication system. This allows for improved maritime safety and navigation, as it provides real-time vessel tracking information over a much larger area. The main advantages are real-time tracking, improved SAR, enhanced coordination, predictive analysis, compliance monitoring, and border control. Thereafter, we have Minotaur system, mission system, that is a cutting-edge maritime system monitoring system developed by the United States Navy. It is designed to provide a real-time situational awareness and target tracking for naval operations, integrating multiple sensor inputs and advanced algorithms. The system is flexible, modular, and can be integrated into a variety of platforms such as ships, aircraft, and ground stations. Amongst the other agencies, US Coast Guard is outfitting its fixed-wing surveillance aircraft fleet with Minotaur system architecture. It uses advanced algorithms to process the sensor data, including machine learning and artificial intelligence techniques. These algorithms are designed to automatically detect and classify contacts of interest and to track and identify vessels. The system can provide advanced visualization capabilities, allowing operators to view the maritime environment in real time. The system can display data in a variety of formats, including maps, charts, and 3D views. Now, what are the systems available with the other countries or in the present generation? What is the way ahead? The way ahead would be artificial intelligence. Artificial intelligence in maritime surveillance uses machine learning models trained on vast amounts of data from the maritime industry of independently evaluate events and predict related risks. Advanced AI and imaging techniques are needed to extract ship features and identities from large volumes of images and data collected by space-based sensors, as transmitters, radar signal, and imagery, providing a real-time view of activity at sea. Another way in which AI is used in maritime surveillance is through the analysis of satellite imagery. AI-based system can automatically detect and track ships in satellite image, even in challenging conditions such as adverse weather or high seas. This system can also be used to extract information from the images such as a vessel size, type, and identification. In addition to this capabilities, AI-based system can also be used for the prediction of future activities of the vessel. To conclude, the growth of global maritime trade has led to the need for improved collaboration and information sharing between agencies, as well as the use of advanced technologies like AI. The expertise of the Center for Artificial Intelligence and Robotics can play a crucial role in this regard, as they can use their skills to develop AI-based maritime surveillance system that can efficiently monitor and secure the seas. Additionally, CAR can design AI-based systems that meet the specific requirements of maritime surveillance and contribute to the enhancement of global maritime safety and security. Institutes like IITs can play a significant role in advancing the use of AI in the maritime surveillance. They can conduct R&D to create cutting-edge AI algorithms and use machine learning to develop innovative solutions for maritime surveillance systems. With the technical expertise, we can also design and create AI-based maritime surveillance system that can be effectively deployed in real-world situations, contributing to the improvement of maritime safety and security. I'm finished. Thank you. Jai Hind.
Thank you, sir, for your time. I'm sure the audience, especially those within the organization, would find the information you shared very valuable. Before moving on with the presentations, I would like to apprise the audience that we now have amidst us Dr. Tessie Thomas, Director General Aeronautical Systems, DRDO. We understand you have a very busy schedule, ma'am, but thank you for taking out the time for joining us. Dr. Tessie Thomas. Moving on to our next speaker, Mr. Anup Kumar Rai is a chief scientist at Central Research Laboratory, Bharat Electronics Limited, Ghaziabad. In a career spanning over 28 years, he has been the chief architect of advanced computing and software solutions for various command and control programs. He has also been responsible for developing software solutions for various non-defense projects. Mr. Rai has received 2 Raksha Mantri awards under the innovation category as well as the design category. The Chief of Naval Staff appreciated his work by giving him on-the-spot commendation for the ATM-based integrated ship data network design.
In the recent years, the rapid growth of deep learning techniques has significantly promoted the potential for developing advanced algorithms for various remote sensing applications such as urban monitoring and sea surveillance. I would like to invite Mr. Anup Kumar Rai to further elucidate on the subject.
Good morning. Thanks to Indian Coast Guard giving the opportunity, sharing the knowledge which we doing in electronics in a special segment C4I I2SR. In the C4I I2SR there are 2 C called command and control. All other are involved in the technology, computer, communication, intelligence, information, surveillance circuits. So it's a big segment where the technology is involved to give the most optimizations of operations. Last 2 decades, more than 2 decades, we are working the C4ISR technology indigenizations in-house. We developed a mega program of Air Force. It's called Integrated Air Command and Control Systems. We work for the Navy, Army, and Coast Guard also, and we deliver many systems. So now I covered my presentations in 2 parts. One is a BL's role in maritime domain awareness, and then maritime surveillance and security using the AI and ML decision supports. So we start our journey from prototype system of where the ancient trial we did in the Porbandar. After 2611, the challenge is that how to be handle the give to electronics eye to our Coast Guard, and the solution should be there. We work there. Then we implement the Coast Guard phase 1. Then another big challenge we have taken for the project Sangray. There is a maritime domain awareness as a part of NC3 project, and the solution is working. And now we have in a phase of the implementation of the Coast Guard phase 2 and the upgradation as per the emerging technology, we are continuous. We are not only work on the country, our footprints are involve our maritime in the Mauritius, Seychelles, Sri Lanka, Myanmar, and Maldives. So these are the total deployments are where the software which we have developed for the Indian Navy as a part of Project Sangray. In a total 51 locations we have deployed. It is a top-down architectures, means data received in the center location and disseminated. The fusion center are centralized here. As a part of the Project Sangray, we have developed more than 500 features of the maritime domain awareness, data analytics solution, highly scalable, highly customizable, image and video analytic, ML-based decision support system, and fault tolerance with disaster recovery. So our solution have the scalable, fuse common operating pictures, image and video analysis, AI-based decision support system, and the display solution have the capability to handle the more than 4 lakh targets in the system, and it's already deployed in 51 locations of Indian Navy and Coast Guard side in Pan-India. This is the architecture which we have developed for the coastal surveillance. Is different than the which we developed for the Navy. Is a hierarchical distributed, is a bottom-top approach where data is collection from the bottom side and information pushed to the top for the decision-making informations. So the footprint is start from Porbandar to Kanyakumari and Haldia. These are the where our software and the solution are deployed already. These are the work we are working. Now what we are doing in the advancement of the marine domain awareness. So first, why space-based surveillance domain required and IDS required? The traditional approach have limited coverage in radar and AIS. It is only sea up to the line and sides. No coverage of small boats in the deeper area. That's why we require the space-based solution, enabling the persisting monitoring on global scale. Technical information such as environmental data, threat assessment with ship location and identification, and high resolution images, and more advanced capability of maritime surveillance. Artificial intelligence decision support in marine system provide the advanced capability of the mounting inside the decision-making capability by analyzing the large amount of data. AI/ML comprehensive and effective maritime surveillance. Comprehensive and effective surveillance can be delivered by assimilating the AI/ML techniques with conventional AIS and remote sensing, imaging, and data. So there are two things where the advancement is required for the remote sensing side and other. Finally, this advanced technology, particularly in the field of the AI, are offering the new opportunity to enhance the maritime surveillance capability and provide the improved situation awareness in maritime domains. So these are the analysis engine which AI/ML based, which we have developed in our lab, are deploying and continuously improving this, which have the kinematic analysis, AIS reporting, traffic analysis, mission recording, motion pattern analysis, threat identity, images analysis, and video analysis. In motion pattern analysis, we are doing the pattern analysis of the vessel movement and anomalous the behavior detection based on the deviation from the normal pattern or trajectory. Motion pattern analysis involves the identification of standard routes based on the density and classify the deviations from the routes as anomalous behavior. Kinematic analysis, also we are developing anomalous behavior prediction using the machine learning algorithm based on the anomaly in the kinematic parameter of the vessel, like an abrupt change of the speed and course. Data spoofing also doing where the data spoofing of the vessel or intentional wrong reporting of the kinematic parameters are also detected by our systems. Now, proposed framework for the AI and image-based maritime is there. From the image satellite station, we will collect all data on the cloud, and cloud to pump the data on deep learning-based objects detection center, and that images will send to scenario and decision making, and finally command and control server for decision makers. So in our lab, we are doing the image analysis with the satellite, where we classify the especially stern and bow of the classification. Then finally we identified the after vessel detections. These are the giving more classification identifications in advance in the maritime domains. Finally, concludes what are we are doing this object detection and classification of the vessel and submarine using the AI/ML, predictive analysis of potential security threats, real-time monitoring and tracking of the vessel movement for behavior analysis, improved the decision making through a deep learning algorithm for pattern recognition and anomaly detection, automated the threat assessment and early warning using the AI/ML systems. AI/ML based system, data analysis of the unmanned aerial and underwater vehicle for increase the surveillance range and coverage. Thank you.
Thank you, sir, for your contribution to our understanding of the AI/ML system. Your passion for the topic was evident, and it was truly a privilege to learn from you. Moving on, the final presenter for the day also happens to be the youngest among our immensely experienced speakers, Mr. Kiran P. Kulkarni, Director Research and Development, Haribon Aeronautics, is a product designer by specialization. Since 2005, he has worked on hybrid VTOL design, that is the vertical takeoff and landing, and UAV designs. He also has numerous publications on the subject. Furthermore, UAVs of Haribon Aeronautics were launched at this very event 8 years back during Aero India 2015.
So far, we have seen various concepts to augment surveillance and reconnaissance operations in the deep sea. But the coastline remains the final demarcation, which we intend to insulate from any untoward incidents. So we would now request Mr. Kiran P. Kulkarni to deliver his presentation on the deployment of fixed-wing UAV and telematics for autonomous surveillance of coastlines of India.
Good morning, everyone. So basically, we are a small company from Bangalore. We are a company which develops fixed-wing UAVs for various military and civil applications. And more in fact, we are a product development company which we synergizing both electronics and aeronautics together. I'm accompanied by Squadron Leader Ramakrishna today. He's my advisor and he's director of the company. So this will be my topic. We'll introduce our company and we'll tell about fixed-wing UAVs, which we are deploying for maritime surveillance, and how we synergize telematics and surveillance together, and what new things we can bring into the table. That's what is my topic today. This is my team, comprising of strong mentors and very enthusiastic technical team, both from Indian Institute of Science, IIT Bombay, and NID Ahmedabad, and we have a quite young team. This is our capability. From conceptual design of aircraft to the product, we have total in-house development capability, and we can customize every single part in the aircraft and make it and give it. So that's our thing. These are some of the products we developed. We started with a small aircraft, a 2 kg class. We name our aircraft by Paramvir Chakravartin. So the first aircraft we made was Sikon. It is less than 2 kilo class, fixed wing aircraft for 20 kilometer maritime surveillance. It can fly in monsoon weather also. We use it for agriculture monitoring. Most of the agriculture happens in monsoon weather conditions, so we use that aircraft. And we have a small aircraft, 1 kilo class. It can fit in a bag and go up to 10 kilometers. It's called ICA. And anybody can just throw it like a javelin, it will go and come back. We developed one UAV for agriculture monitoring. Basically, it's a UAV, multi-purpose UAV. It can carry any payload. We have got a long-range fixed-wing UAV we have developed recently for maritime surveillance. And this aircraft is what we are trying to use it for maritime surveillance. Apart from it, we have a full-fledged electronic lab in our company. We started with vehicle health monitoring. Basically, telematics came from mining requirement. They wanted to monitor vehicles, and they wanted to monitor health of the vehicle. That's where we started. Then suddenly, tractor industry wanted these devices for put in every tractor and monitor every tractor. And later, when we were working for a fisheries department, a few fleet owners came and spoke to us. They wanted to monitor their fishing boats. These boats are less than 20 meters small boats. They go deep into sea and they don't know what's happening, whatever they did. So that's where we conceived the idea and we made a device. So now coming to the thing is, when we make this UAV and telematics, we have these communication devices. RF communication is our default element in our aircraft. We integrated telematics with RF device, and that became a solution for these boats. That's what we are trying to make it. So current scenario, I'll not go through this because in fact, everyone knows about it. Now, in fact, dependency on satellite communication is there. So somehow we want to reduce that thing and try to introduce a new technology where we communicate with these small boats all the time. So coming to references, what we did, because before we started, a lot of publication from ICG gave us the pathway. Basically, your reports and your presentations, which are available in public domain, in fact, set the tone for us to decide what we want to do. So in all these areas, what we address, the top one, the frequent, the problems of fishermen, that is the area we wanted to address. And there is another major enlightenment we got through these open domain document is absence of AIS device on less than 20 meter length boats. And another thing is the devices are very expensive. So these two addresses, thing. And there is one more question what these fishermen told us, ये device डालने के बाद हमको क्या मिलेगा? At the end of the day, ICG will take the data and what will I get? So that also set the tone for us to make a device from which they get also benefit and ICG also monitors everything. So that is our goal. And also we studied some of the reports by state governments. So in this particular thing, in fact, they also mentioned about sat phones not working, network issues, satellite issues, all those things are there. And also the most important thing is a common platform to be prepared for all this database, which is coming through these various means. So now we made basically this slide I added because there's a request. Because there are various configurations of UAVs available for ICG. If you classify, there are 5 major configurations will emerge, like a regular quad rotor, hybrid, and fixed wing and helicopter. With our experience, I can say fixed wing UAV and hybrid helicopters are best suited for long range monitoring purpose. VTOLs have got their utility, but when it comes to 100 kilometer and plus, fixed wings are the thing. So this is the UAV what we have developed so far. It runs on 20cc petrol engine, and it can carry any payload what you can demand for, like transponders, camera is a default thing, and RF, and we can carry other special items also. And operation cost of this drone per flight or total flight is coming to somewhere around 4,000 to 6,000 rupees, that's it. So we are making a solution which can be deployed both from shore and both from ship. Like it can be launched through a launcher and it will come and hit the net and it can be recovered also. So that's a system we are developing. And this is the telematics what we have. So in this particular thing, we have 16 channel data available. And we've got an IMU. I'll tell you why IMU is required. We've got a GPS, GSM, and RF. RF is a new entity. Generally, in telematics, we don't use RF. This RF is introduced for fishing boats. So now this is the point what, humko kya milega, the question. This is the answer for them. So what would happen is, basically we can monitor the health of the boat. That is beneficial to the operator. Live status to everybody we can transmit. Details of entire path covered by the boat can be monitored. The next is multiple communication options are available. GSM will be there. Till the GSM network is there, tracking these boats is as good as tracking a Uber auto. Beyond that, RF will take over. So we have RF ranging 80 kilometers, 40 kilometers. Quite often we use them in aircraft. The same unit can be used in these telematic devices. So we have got dual redundant GPS on board and also triple redundant power supply. If somebody sabotages power, this device can power itself for 7 days. So that's how we are trying to make the device. Now, how do we club this? At the end of the day, operations are very important. We have to club this thing and put it into use. So now, moment we, let us say we have a UAV in place. If boat is within the vicinity of a vessel, it will directly communicate to the boat with your vessel. If you have RF load which can track the data, the same RF can communicate the data. And if a UAV takes off from boat or from the shore, same RF device can immediately connect with the UAV, and that UAV will become a relay station for you. It can communicate to the boat, communicate to the shore. So at the end of the day, when we deploy these devices in 20,000 or 30,000 boats, we end up with lot of data which comes into the servers of ICG. Once this quality data is gathered, then comes your AI and algorithms and implementation of these algorithms and planning your actions based on that. That can happen. So how do we deploy aircraft? Like, let us say we take off from a Karwar, a fixed wing UAV with 100 kilometer range. The moment we take off, within the range of whatever the RF range which is available about kilometer when we build up the height, every fishing boat which is there in the thing, through RF we can track it. That's number one. Also, if a fishing boat is there, already the GPS location of this entire log will be available. You will know the origin. If this boat is coming from Karwar and this boat is coming from Mangalore, that can be tracked. And the moment this entire device, when the UAV takes off from the vessel, because when you go deep into sea beyond 50 nautical miles, these fixed wing is they're operated from the vessel. The moment we take off, there are two circles you can see. The red circle represents the direct communication from boat to the ICG vessel, because there is a line of communication available from between two antennas. For the beyond that particular range, the moment we take off the fixed wing, it can easily travel within 1 hour or 2 hours. You can cover large area and all data will be available to you, including the history of the travel also. So this is the concept we are trying to develop. So at the end of the day, advantages with this kind of technology would be, like fixed wing UAVs can handle weather. It can fly in rough weather conditions. You don't have to bother for it. Even if it falls in water, it will float actually. You can go and recover and do some repair and use it again. That is very important. And the second thing is it can carry many types of payload. There is no restriction in payload. Maybe my operation envelope of the aircraft will change. Maybe I can fly a little faster when I carry a little more payload. So that is the thing. It can cover range and endurance. You can make this aircraft what we have currently, about the one what you saw, that's 2 hours. Already we have another aircraft for 4 hours. So we are upgrading the technology already. And of course, we can do beyond range this thing. To the users, in fact, we can monitor the health of the boat. Because IMU is present, we will know how the boat is working also. We can give that data. And reduce dependency on these, what we say, sat phones and other traditional thing, even though they will be present. But alternative communication system will be also, it will be deployed. So that's what we are trying to work for ICG. And of course, these are new technologies. We have to do it in a partnership mode. We can start the deployment and see how it works. And then later we can expand it to the entire country. So that's what is my goal. And thank you. I thank ICG for giving this opportunity. It's quite overwhelming for us, a small company, to present our concept here. Thank you very much. Thank you.
Thank you, sir. Your commitment to your subject was evident, and it was truly an honor to hear from someone who is dedicated to make a positive impact in the field.
Ladies and gentlemen, with this we come to an end of the presentation session. We will shortly commence the panel discussion, requesting the audience to kindly remain seated in their respective positions.
Samudra Vasane Devi Yatra Tatra Sarvatra. It means here, there, and everywhere. And for us in the Indian Coast Guard, there could not be a truer saying. Being omnipresent is no easy task. But when the security of your country and its citizens are at stake, there can be no half measures. On sea, in the air, and from the land, we are truly Sarvatra. Be it answering a call for help, or preventing extremists, guarding our resources, or saving the environment, braving raging seas or enemy bullets. We do what we are best at. We protect. Being the guardian of India's long coastline isn't easy, especially when we have to keep more than 2.37 million square kilometers of India's exclusive economic zone safe and secure. But nothing escapes our watchful eye. We are vigilant at all times, at all places. Eager to serve, always ready. Each of us has stood the test of time before becoming worthy of the honor that we protect. Serving shoulder to shoulder, content in the knowledge that we are all for one and one for all. And we believe no resources are enough when we are needed to protect our sovereignty. And our responsibility of search and rescue operations extend to over 4.6 million square kilometers. After all, making 1.4 billion people feel safe is no mean task. And isn't always easy sailing. There are many a fire to put out, literally. But we don't work in isolation. Community means everything to us. They are our eyes, our ears, and we are their friends and saviors. And the sea is not just our workplace. It's where we breathe and live. It's our responsibility. We have to earn its trust and nurture it and protect it. We also take care of our own, making life easier and a little bit better every day. The ties of brotherhood mean the world to us, and it helps to belong to an organization where we each have our back. Because despite the sea being unforgiving and the elements harsh, our responsibilities stand clear. We guard, we enforce, we rescue, and ultimately, we protect. We protect this land and this nation, which we proudly call home. Vayam Rakshamaha.
Ladies and gentlemen, moving forward, we will now commence the panel discussion on the subject being addressed. We have a distinguished group of 5 panelists, and I'm confident that the discussion will be both enlightening and thought-provoking. Moderating today's panel discussion, we have among us Inspector General Donnie Michael, Tatrakshak Medal, Deputy Director General, Coast Guard Selection Board. The flag officer joined Indian Coast Guard on 6th July 1990. His qualifications include Masters in Maritime Affairs from World Maritime University, Sweden, Search and Rescue course from Singapore Aviation Academy, and he is a fellow at Narottam Morarji Institute of Shipping, Mumbai. To further hone his professional competence in the vast maritime arena for law enforcement, he completed his legal education by obtaining LLB degree from the Delhi University in 2011. For his brave display of leadership in saving a burning merchant vessel near Mumbai in September 2012, he was awarded the Coast Guard Gallantry Medal.
Moving on to our panelists. Our first panelist needs no introduction. It gives me great pleasure to welcome Dr. Tessie Thomas, Director General Aeronautical Systems, DRDO, whose achievements and qualifications can humble the greatest of minds. Dr. Tessie Thomas joined the Institute of Aviation Technology, Pune, as a faculty member in guided missiles in 1986. She was associated with the Agni program right from its developmental flights. She has designed the guidance scheme for long-range missile systems as well as underwater weapon systems. In her work spanning more than 34 years, she has contributed in various fields and has spearheaded the Agni 4 and Agni 5 projects as project director. She currently leads the Aeronautical Systems Cluster Laboratories as Director General with the responsibility of design and development of state-of-the-art UAVs, manned and unmanned aircrafts, and many more projects for the armed forces. No new name to prestigious laurels, Dr. Thomas is also the recipient of Lal Bahadur Shastri National Award for Excellence in Public Administration, Academics, and Management.
We also have among us Deputy Inspector General Atul Agarwal, Commanding Officer, Coast Guard Air Enclave, Cochin. The officer joined the Coast Guard in July 1997. He has commanded various units, both ashore and afloat. An Alpha Master Green Dornier pilot and a qualified flying instructor. His professional excellence has earned him numerous commendations in the Indian Coast Guard, Indian Navy, Indian Air Force, and also by the Honorable Governor of Andaman and Nicobar Islands. The officer has also completed the Global Maritime Distress and Safety System course.
We are honored to have among us Mr. Sanjeev Venkateshan, Global Director Capture and Capabilities, Raytheon Missiles and Defense. Mr. Sanjeev is the capture lead for Indo-Pacific Command region in land warfare and air defense systems. His management, technical and research expertise lies in the area of artificial intelligence as well as electronics and embedded systems. After supporting development activities for the ballistic missile defense program, Mr. Venkateshan supported the software subcontract manager on future combat systems. Continuing their contribution to the seminar, now as panelists, we are fortunate to also have on stage Mr. S. Padmakumar and Mr. Anup Kumar Rai. With the audience now apprised of the sheer volume of knowledge and experience that we have here, I would request Inspector General Donnie Michael to kindly commence the panel discussion.
Thank you, everyone. Good morning. At the outset, I want to thank everyone present here this morning for the seminar on the most important and vital topic of maritime surveillance systems and assets. The chief guest of the inaugural session had touched on all the vital aspects and issues of the maritime surveillance and its importance in the context of the Indian maritime security scenario and the geopolitics. In today's panel discussion, we have a combination of highly eminent scientists and technologists on the one side and a user of the technology, an ace pilot over here, and the officers manning the operations center such as me, who analyze the data for further action, particularly the response action. It was fascinating to witness the presentations made earlier, and it is heartening to note that in future, most of the decisions will be made by the missions, and it is becoming more important now on how to keep the users, such as all officers over here, to be more relevant amongst the intelligent systems that will be surrounding the users in the future. Having said that, I just want to start these proceedings for the general knowledge of the young audience sitting behind, to note that Indian Coast Guard, which is formed on 1st February 1977, post amendment of the Constitution made by the Government of India to claim the jurisdiction and the sovereign rights over the resources in the Indian maritime zones, which was claimed post passage of the Maritime Zones of India Act 1976. To undertake a vast maritime surveillance in the new zones that has been available over time. As a seagoing officer, I take my example. I can clearly remember when I joined in early 1990, what I did is the first 4 years is just do nothing and keep watching through a binoculars or through my eyes. That was the most solid technology that was available because I can detect and interpret many other things. And later we were told to use the radar and afterwards interpret the data and the contact details. As we progressed, we started using the ARPA, the Automated Radar Plotting Aid. Then we had this ECDIS, Electronic Chart Display and Information System, the Automated Information Identification System, AIS, and IRUV, and lately the inputs from the Maritime Domain Awareness. These are the progress we made, but however, still I can say every commanding officer on board the ship would love to have a watchkeeper to take his binocular and keep watching, to undertake the analysis and to analyze the intent of the vessel and also the users of the vessel. I think after hearing all these presentations, that domain will be particularly taken over by the missions. Having said that, in today's complex and evolving maritime threat, maritime scenario, a maritime threat places a great premium on the knowledge and understanding of the parameters that can pose a threat in the security. Post 9/11 and incident in US and other maritime security incidents around the world made the international organizations and nations to completely revamp the maritime security, which was operating on the principle of mare liberum, that is called open sea, on the principles of freedom of navigation, to take all measures to prevent interference with the lawful usage of the seas. The ultimate purpose is to make the sea access and to deny the access to the target so difficult so as to discourage the attempt. And proper maritime security creates a condition which establishes and maintains certain protective and preventive measures. These protective measures, which may vary in the application in different states and maritime regions, must be capable of all instances of performing two important tasks. That is, timely and an accurate warning of an impending threat, and the response for removing or neutralizing the threat. Without adequate warning, the best security force may fail to protect its interests, and conversely, without the ability to respond, the adequate warning is useless. We know how the Coast Guard has developed and has had the potential to repel any situation developing at sea, and its response capability has been improving. Accordingly, now the key element to effectively countering any threat is early detection. This cannot be achieved in a complex maritime domain like peninsular Indian coastline unless gaining a consistent and persistent awareness and the domain knowledge. Today we have a panel of eminent experts and speakers and users of the maritime surveillance system and assets with us today. And without much ado, my first question is to Dr. Tessie Thomas, Director General Aeronautical Systems, DRDO, a distinguished scientist and having a distinction on designing the guidance system for three-stage solid rocket system design and development of state-of-the-art UAVs and airborne surveillance system for the armed forces. May I now request Dr. Tessie to throw some light on the technological advancements being made on the maritime surveillance systems and the Government of India efforts towards these said efforts. Thank you.
Thank you. As you are aware, the maritime patrol aircraft technology, there are two sensor level technologies which has given us the advancements in this case, where in MPA, the maritime patrolling aircraft, anti-submarine warfare, maritime domain awareness, and pollution surveillance and search and rescue operations. These are some of the advancements in the MPA technology, wherein which the state-of-art technologies like airborne AESA-based digital maritime patrol radar, using the GaN-based, that is a gallium nitrate-based TR modules, and FPGA on chip, which gives us a direct benefit of digitalization and thereby improving the overall accuracies with respect to our conventional rotating radars, wherein which we benefit on the detection performance, clutter cancellation techniques, the improvement in LPA, that the low probability interception, and adaptive jammer cancellation. These are some of the techniques which has been able to be achieved with the AESA based radar systems, and wherein which we get overall operational improvement in periscope detection, terrain imaging as well as mapping, and detection of long range vessels and identifying them to the closest. The other sensor advancements is on the electro-optic and IR systems with multiple payloads, such as the high-density day cameras with the wavelength, the medium wavelength IR as well as the short wavelength IR, very high-density IR cameras which acts as sensors for thermal imagery, which basically uses the advanced CMOS, the metal oxide semiconductor, devices with focal plane arrays, which again gives us the capability to have the detection, recognition, and identification in a very improved state with performance and resolution under stringent atmospheric conditions. As I mentioned about the shortwave IR based cameras, which is, gives us the benefit of seeing things which is under, even under smoke, clouds, and haze, we can detect the object, whereas a medium wavelength IR cameras gives us the benefit of seeing the gases which are gas leakages, which we cannot see through the human eye. And these are some of the sensors which has come into greater advancements with respect to the performance improvement. Then advancements in sensors, like for the pollution surveillance, we have great accuracy of the surveillance output has been achieved. For example, if you use the sensors with the laser fluorosensors and microwave radiometer, they help in detecting and identifying the type of oil spill. And as mentioned by the morning speaker also, SLAR, the side-looking airborne radars, will help us to know the extent as well as the area of this oil spillage. And DRDO has taken up developing these two advanced technologies, the state-of-art airborne system, the multi-mission maritime aircraft, MMA, for surveillance of offshore development areas. And this MMA, to have these advanced sensors with the AESA-based maritime patrol radar, as well as the EO and IR pollution surveillance suite also. Now, with these two technologies, these individual sensors combined in an integrated form with the MPA, fusion of surveillance information through multi-sensor data fusion, and the technique which we can improve upon the accuracy. Further, it will again help us, this fusion combined with AI-based techniques. It will again improve the situational awareness provided by this MPAs. And complex mission control and signal processing software also gives us the flexibility in future upgradation without depending on any other external agencies. We are in a position today, DRDO has taken up this task of making the MMA for the Coast Guard.
Thank you so much, ma'am, for providing us with vital information. And I'm particularly interested in onboarding the pollution surveillance and the short-range IR cameras to detect some gas leakages, which is not visually we can appreciate at sea. Now, moving on, we have with us another distinguished panelist, Mr. Sanjeev Venkatesan, who has traveled all the way from US to Bengaluru today. He is a global director, Raytheon Missile and Defense. Having observed the Raytheon advancements on surveillance technology myself, and I think I can make use of the vast knowledge and the expertise available with Mr. Sanjeev Venkatesan. And accordingly, I have two questions for you. The first one is, how Raytheon approached the maritime surveillance to optimize the maritime operations? And the second is, what is the Raytheon perspective on optimizing the assets for the integrated operations at sea?
Thank you so much. You must be wondering why I'm keeping this seat warm in my jeans here. It's a pure failure of maritime surveillance across the ocean because the airlines lost my luggage and I could not find anything else to wear except for what I was wearing when I was traveling. So here I am for you. I'm very fortunate to be part of Raytheon for the past 28 years. What I've observed and experienced and exercised within Raytheon Company is the relationship with our end users is very critical for us to understand the requirements because maritime surveillance is a very complex topic. Maritime surveillance is a multi-domain operation, multi-domain awareness, and multi-mission capable capabilities and resources that you have to bring to the plate. And it all starts with the command and control. You have to understand that we at Raytheon partnership with the user to understand what are their ConOps, what are their use cases, starting from the top, what are their decision-making authorities, because when you do maritime surveillance, you have to engage with multiple agencies, and each agencies have their own rules, regulations, procedures, and processes. So how you filter the information from one agency to another agency to reach the decision is very, very critical. What Raytheon has done is focuses on a lot of modeling and simulation capability in order to model use cases, to partner with end user to understand their requirements in detail. And everybody brings their technology and product together. But when you design these products and technologies, what we have experienced is it's done in a silo with a particular service, with a particular set of requirements. But in maritime surveillance, you have to operate these things in a peacetime, as well as you have to operate this in a wartime scenario. Maritime surveillance, the Coast Guards have the challenge of economic reasons, environmental reasons, climate reasons, human reasons in order to operate and make sure. In the news you must have seen right now that we are shooting down some objects from this space. They're trying to fall down in a coastal area where we have to recover the payload. All this takes a lot of planning. Raytheon Products is right in the middle of it. You know, my department's missiles are actually engaging these objects right now, which is nice to see that it is working perfectly. So these operations require a lot of decision-making process. So that's where artificial intelligence comes in. I've been in AI for about 28 years. It is a very cyclical thing. So what I would like to advise the industry from our experience perspective is we always tend to overpromise with artificial intelligence and result in under-delivering. This is my 4th cycle of artificial intelligence that I've experienced. So what we are doing is we are carefully limiting the ability and capability of what we can deliver to the user with respect to artificial intelligence. When you talk about defense, we cannot automate a lot of command decisions to the machine. It can assist us in making the decision. Underwater submarine warfare, or underwater vessels, or underwater targets you're talking about, how you engage them, the ConOps. Each system has to talk to each other very, very carefully. So integration is going to be very, very important. Now, the data in the maritime domain is in the order of magnitude when you talk about processing. So our software with the command and control communication and the data fusion perspective, it is very important how you do collaboration, how you do ID, how do you do detection, how do you classify, and how do you actually parse these data in order for peacetime and wartime, in order to give the right information to the right level at the right classification level. Thank you.
Thank you so much, Dr. Venkatesh. I completely understand the issue is stated on multi-agency, multi-stakeholder construct in the maritime arena. It's not new to the Coast Guard also. I'm glad to hear that how Raytheon is involved in detection and identification of a rogue flying object over the airspace near country and the neighbors, and the solutions provided for the suitable response. Now, moving on to the next panelist, we have with us Mr. Anup Kumar Rai, who made a presentation earlier. He's the chief scientist at the BEL, Ghaziabad. He has been the chief architect for advanced computing and software solutions for various command and control systems, particularly the coastal surveillance system that the Coast Guard is operating. I particularly remember the algorithm being developed for a decision support system because we had the radar and we had the control center, but we don't know what to do with that. So, because we have the radars picking up the fishing boats in a cluster, but we don't know who's operating and what is happening inside the fishing boats. So I was recommending to your scientists, to give us some solutions, at least to identify amongst them who are the rogue elements. At least give us some parameters. When a fishing boat is not moving for more than 6 hours and it's been staying there for more than 2 days in a particular place, or is going at a speed more than 12 knots, which is the maximum speed of a fishing boat, those are the things they adapted and given to us. Now it is interesting to note the Coast Guard is going for phase 2 of the CSN, and I'm sure Dr. Rai, he's going to incorporate machine learning and artificial intelligence in the software system for the phase 2 of the coastal surveillance system. My question to Mr. Anup Kumar Rai is to throw some light on the advanced computing programs being incorporated in the phase 2 of the CSN system, and what kind of advanced decision support system will be available to the users such as the Coast Guard in future.
Thank you. In 2009, we had started the Coast Guard solution. That time, the technology, computing technology, have the limitations. But nowadays, you see the ICT is expanding in a big way. The server is coming in the GPU server, where our scientists are doing a lot of modeling. So we will be giving the first time giving the answer. We are giving the motion pattern analysis, kinematic analysis, AI spooking. All these features will be available in the Coast Guard Phase 2 software. And toward the technology front, like Madam is given the airborne sensor. When the sensor is grow, but ultimately the sensor giving the data, and this data should be do the analysis properly. So nowadays, the main crack of the improvement of the situational awareness is come to the part of the decision support systems. And the decision support system, conventional decision system is a rule-based engine. Now, from rule-based engine to is moving the machine learning-based systems. In this machine learning system, the accuracy of data and all other technology should be integrated, because the data is coming from satellite image, data is coming from UAV, and all this help us to improve our situational awareness by first detections, classifications, and identification, and all these communications which are increasing, and the solution which are doing in the command control system ultimately reduce the OODA loop. And this OODA loop will be finally give the seamless objective of the operations. So operation will be optimized with coherently with the technology. So we will ensure the forum, the bulletin is continuously working on the advanced computing solutions, especially for, and we have especially 2 wings which are working on the research and technology. Their objective is to take the BL's R&D in the next level, and we have the another work, it's called the research and development groups, which are continuously develop the solutions. And our focus in doing the blue sky research, and through the blue sky research with the cutting edge technology, provide the command and control system, especially for AI ML based decision support system. Thank you, sir.
Thank you so much, Mr. Anup Rai. I completely agree with you, because when the phase 1 came, both from the BEL and from the Coast Guard, we didn't understand what should be the next version, and how to scale it up. But as we gained experience and knowledge on how to operate and how to interpret certain data, we came to you and you openly gave us a lot of support. I think we'll get this support in future too. Now we have with us DIG Atul Agarwal, an ace Coast Guard pilot and a qualified firing instructor who have a vast experience on aerial surveillance and maritime operations. DIG Atul Agarwal, can you throw some light on the advancements made on the Dornier aircraft, on the surveillance system for surface detection of targets, and your experience of using these systems over the years? And also, can you throw some light on the recent operation undertaken by the Indian Coast Guard for responding to MT New Diamond? And as a Dornier pilot point of view, what suggestion can you recommend for integrated maritime ops? Thank you.
Thank you very much, sir. Sir, thanks for the question. It's a very relevant and it's a question which touches all of us. As I have operated Dornier aircraft for 25 years nearly and seen various things. As we have seen, we have graduated from supersonic radar to ELTA. I remember a particular situation that we were going for Tropex and we were fitted with the ELTA radar for the first time. And the moment Dornier got airborne, our observers picked up the entire fleet. The CNC has to reposition the fleet 2 times, but still our ELTA radar was so strong that we could pick up the fleet any time. The radar system is so capable that from 40 nautical mile you can see the runway lights on the radar. Coming to the other parts of the domain, which is the maritime domain, we have seen a tectonic shift in the vessels which we have now. They are far more technologically superior to the previous vessels. The reliability of machinery has gone up manifold, and the operational capabilities and the patrolling capabilities has gone up manifold. And coming to the other last part of the question, sir, as Mr. Sanjeev had mentioned, it may not have got so much notice, but I would like to underline the fact that we tend to over-promise ourselves with the artificial intelligence. And if sir may agree, it is just like artificial intelligence still cannot give you more than 50% of accuracy in terms of decision making. So decision making has to be done by the top commanders. And for that, what we have discussed, the data integration from the various sensors, whether it is coastal network sensors, whether it is an element on patrol, whether it's a surface element or UAV, the data has to be linked and passed on to the domain experts. The domain experts can still make, because decisions cannot be made on the past policies. They may be affecting our future policies. And also when we are deploying these kind of system, we have to be very careful that we should not land up in a situation of vendor lock-in. If we get locked in with a vendor and he only has a proprietary technology, whether in terms of hardware or software, then it will be a very difficult situation for us. As sir has mentioned, now the threats have, the UAV supporting us is a threat for me as a pilot. I don't know who is launching, like at times some people, they do experimental test flight, and we have seen now tactical UAVs which are called, which are operating a short distance. So we have to develop a system in the aircraft to have a detection for these UAVs also, because these UAVs are operating a particular frequency. Either they will be remotely controlled or they will be GNS controlled. If it's satellite controlled, we should know which receivers are there operating. Otherwise, they pose a threat to the aircraft. Just for the information of audience, for this Aero show, there is a complete set of air defense units have been deployed at the Army to provide mainly protection in this hinterland from the UAVs. The picture which is coming has to be stitched. We have the picture coming from eastern seaboard, we have the picture coming from western seaboard. When it is reaching the CGHU, it has to be stitched into a holistic picture. Then only it can give a better, like officer has talked about long range tracking systems. We have various limits of the tracking system, but these tracking systems and the information which is coming has to be stitched and made actionable intelligence, meaningful intelligence. And the last point which I want to put across, the satellite technology or the technology which is advancing at so fast. If we acquire a technology today, when we are talking about various stages of implementation of coastal guard networks and other things, if you don't implement it in time, maybe 3 years we will have it as obsolete. We cannot promise ourselves that what we are having technology right now with us in the room or in our, even in terms of mobile phone, will be useful for us in coming future. And availability of satellite technology with the asymmetric threat is a very big challenge. Thank you.
Thank you, Atul, for your insightful information. And finally, we have a panelist, himself the ex-commandant of the Indian Coast Guard, S. Padma Kumar, Managing Director of Engrav Aviation, And having viewed your presentation, you posed a very important questions, what is there, what is he doing, what is his intent, and how do we interpret his intent? And you said, in future, the machine language and the artificial intelligence is going to, uncover that intent for us. But it's having seen your presentation, it's like a movie seen up to interval. I want to ask, what will happen to the second part of the movie? I just want to ask, what do you perceive, the usage of machine language and artificial intelligence on the aspect of identifying a potential threat in the maritime domain?
Yes, indeed. Yes, it was a movie half played. It was deliberate. Because I never wanted to use this forum for browbeating of what we have. But then now that you have prompted, I have no choice but let me do that. We have spent 13 years of R&D time, funded ourselves, made a 100% made in India solution, which is mainly taking care of the assets. Now, when I say assets, it's the ships, aircraft, hovercraft, UAVs, any type. Now, this caters for all the operations, maintenance, and logistics, sustainment support requirement of these assets. Having sailed on board as well as having been in the aviation, and what very rightly and permit me to say that maritime surveillance is a very complex domain, as Mr. Sajeev said. When you are out at sea and when you see multiple contacts and the whole lot of fishing boats going out of harbor or coming into the harbor, you need to know who is who. We have an AIS, I told about the AIS being manipulated. Now, what needs an integrated approach? The first thing is that we all talk about AI, ML, but then data is like oil. And without oil, engine cannot run. It's as simple. So, first is to have the mechanism to have this, all these assets into the system. Then the data comes in. Now, what are the data? We all talk about surveillance data, of course, onboard surveillance data. We have asset data. There are a lot of operation and maintenance and sustainment support data. And in a real life scenario, when you are out at sea and when you are going on full speed for an interdiction, and if you lose one engine, what next? Your speed has reduced. So all these things are brought into one ecosystem. Then comes the the surveillance data. Now, we have fortunately the ISRO constellation, Navi constellation, 7 of them are already in the orbit. In the next planned period, another 4 will go in. So we have 11 satellites, and we all know what happened in Kargil time. And so we should not end up in that scenario. So Navik so that brings in the satellite technology. So one component is there, satellite. You have the assets, a multitude of assets. That is there. So we need to integrate that. Most important thing is the user. The user, as very rightly said, on a click of a button, you cannot say fire or not fire. So it has to be a human decision. So the human behind the machine plays the ultimate role. Now comes the last part is the AIML. So at no stage, I think we should leave the entire system to the AI engines. Now, but what you can do about it? Today, when an aircraft goes for a 4-hour or 5-hour sortie, MR, maritime reconnaissance, the observer, he sees multiple contact on the radars, over the radar screen. It looks innocent, it's ignored, obviously. Now, this data is not recorded. What is interested is to see either to go to a spot where there's a pre-intelligence available, or he happened to see an action there. But the amount of number of sorties flown, the flying task over the sea, the patrols done by the ships over the sea, and this data, which is innocent looking in first go, but this data, if it is available, the machine has to be learned. That is why it's called machine learning. Now, the more you learn, more deeper your data, or your data size is more, the deep learning they say, your machine become more intelligent. If you teach them with skeleton data, it will not be intelligent. So more all this data which is acquired through the regular air sorties as well as the maritime patrol is, though it may not look, and it is not there, we are losing that data. If it is acquired and stored and used for machine learning, and over a period of time, your decisions, your inferences coming out will be accurate. Now, maritime surveillance, in my assessment, should not be seen only in isolation. You have a whole lot of law enforcement need to be done. You have SAR requirements. We talked about pollution response at sea. So different use cases are there, and somewhere it has an interrelation. So the whole mechanism, the user, the assets, the data from the assets, when I say data, it's just, let's not oversimplify it. It involves the operations data, the maintenance data, the logistics, sustainment support data. Not only for sea assets, air assets. So we talk about sea air coordinated operations, it naturally is going to happen. So then comes the analysis. Analysis is probably the most easiest and the last part of it. Because as long as, and the technology is moving. Now, just to amplify on this Made in India solution which we have for it, we have signed with, we are working with IIT Chennai, and we are signed MOU, and these use cases are being worked upon, but we are focusing now on the civil aviation. That's for the fuel consumption optimization, and for the civil aircraft, and sustainment support, multiples. Like if a configuration of an engine or an aircraft determines the fuel consumption. So you cannot say fuel consumption in isolation. So the answer to your question, yes, what I said is the second part of the movie. We have the solution, 100% made in India. We have the association with one of the academic institute, which is IIT Chennai. MOU is in place. We have already started working, and the current focus is, and we need a captive customer, because most of this thing you need a design inputs. So an aircraft manufacturer or an engine manufacturer, they are the right people to support us. We have been talking to Rolls-Royce, and one of that. The other agency could be a country's military. So we need a captive support, and for that analysis part of it. We don't need any support from the other part of the data. So this is where the ecosystem is. Answer to that is yes, ready for deployment and standing by.
Thank you very much, sir. So wonderful explanation of the second part of the movie. Now, I have to wind up. Before that, I thought I can make use of Mr. Sanjeev Venkatesh's domain knowledge. We keep talking about the chat GPT. Can a Coast Guard or any maritime force can have its own chat GPT and take inputs from the machine or through a chat GPT, all ultimate answers for any maritime challenges. Do you think it will going to happen?
Hello? Yeah, I think it's going to play a major role going forward. I think the discussions focused here are all on mission and mission completion. But there is a whole entire ecosystem with the maritime surveillance and operation that has not been discussed here, which is training, logistics, maintenance, repair. The assets that are going to be deployed, whether it's airborne or whether it's vessel-borne or whether it's long-range and short-range surveillance radars. all these require different type of maintenance, different type of training, integration of it. I think that's where the technology such as ChatGPT and other artificial intelligence base that is being developed in the commercial world can be tailored and applied in order to train the users, train the maintainers, and train the servicemen who are going to actually use the system. And it is going to become basically a part of their item when they're deployed, which is going to be a handheld device. They can get their information in real time and get updated information based on these type of knowledge. So, but I also want to emphasize that the AI can also be applied as our distinguished keynote speaker had suggested. There are many elements of his speech was very, very critical to us to really understand in depth. Cybersecurity, information assurance, all these things can be tested periodically. Fault isolation can be done to make sure whether we can predict any intrusions. All this can be done in AI. That doesn't have to be the mainstream of the operation. Thank you.
Thank you very much. I think the aircrafts flying over us is indicating we have to wind up this session. But I also have another task of entertaining a few questions from the audience. And if there are any questions,
good afternoon, ladies and gentlemen.
Madam, my question, after listening to all of you, we are very much understanding that as far as maritime surveillance requirements are concerned, there are a lot of desirables. There's a long way to go. Dr. Venkatesh of DRDO spoke about MMA and said that how there is going to be a decision support system by fusion of data just at a tactical level. People talked about maritime domain awareness, which is happening on land to a huge extent, including use of Athena software in NCQB and other products. Including our representative from Bell talked about his solutions he's providing for coastal surveillance system phase 1, phase 2. At the same time, when he asked about ChatGPT, and he said about few more things which are left out, training to logistics, overall machine coverage. And Shri Padma Kumar, he says that he has got 100% made in India solution. I have a very challenging question for you, madam, because you represent the government and we will be coming to you for the solution. There is something happening very tactical in the oceans, and oceans are far deep inside. Let us not keep imagining the coastline. Let us go up to 200 miles with the Coast Guard limit. There are a lot of data fusion happening on land. There's a tactical level data fusion happening on the scene by an aircraft or by a ship for the future. But the cross-pollination of this data fusion is going to be my most important straw in my victory. How are you going to imagine that for the future?
So that is the most important is the sensor data fusion technologies, what we have to use, starting with satellite-based information as well as shore-based information, combining them. A network-centric control has to be there as far as what you are seeking when we are deep into the sea. And of course, you can have systems capability with UAV, which is again high altitude, which can take off from ship-based systems or from a vessel. That is the future. Like if you look at, we need to have a network-centric effort of all the sensors, which we are saying about, like MMA, which giving all capability of electro-optic sensors, image exploitations, all these techniques based on artificial intelligence coming up, this is the way we have to think a long lead solution for this approach in the deep sea. Thank you, sir.
Sir, about the chat GPT which was mentioned, just one small thing, that artificial intelligence machines are not generally connected to the live data. Even chat GPT is not connected to live data. Even if you ask a question, what will you predict for something, he says that I am artificial intelligence not connected to the live data.
Means the man-mission connectivity is as on today, the deficiency. We have to get into through the networking. That's what we can.
Sir, I have a
Go
question.
ahead. Yeah, please go ahead.
We discussed about various aspects of AI and ML. And specifically, I've seen that the chief scientist, Mr. Rai, has given cloud computing also as a solution for maritime surveillance and monitoring. So basically, none of us discussed about edge computing. So take an example that, okay, we are using AI for this purpose. So the major part of AI that we are going to use is computer vision, where you are getting an image or a video and processing it. So if you are sending the data to the cloud server, because the deep inside the sea, you don't have the 5G network also, it's not there. It's all satellite communication. So the data latency going to be a major challenge there. And assume that a senior officer, a captain of the ship, wants to take a decision of a moving object. The data is sent to the cloud server and he is getting a response or the analytics report after a few minutes. So that will be a decision making issue, because we need to have the data processed at the spot itself with the edge computing. So I feel that we need to consider that edge computing also for this. Unfortunately, I didn't introduce myself. My name is Ajit Kumar. I'm the Managing Director of Infinox Technologies India. So Infinox is a Canada headquartered organization. We are supporting Babcock International, which is a company manufacturing warships and submarines. So we had this discussion where edge computing, how we can use it for effective surveillance. Thank you, sir.
Thank you. Is that an explanation or a question to?
No, my question is, okay, why we are not considering edge computing? Because technology is getting advanced, and edge computing is for this type of processing where we need to have huge set of data processed as part of deep learning, especially Mr. Srinivasan, right? Sorry, Venkatesan. So Venkatesan has mentioned about the time factor that is becoming very crucial. So I feel that why we didn't consider edge computing, it has to be there.
I think I understood the question. That he's talking about image computing and of the having a large data, and we not having a 4G or 5G at sea. How are you going to process this large volume of data? Are you going to use the cloud computing through some other interface or something? Is what he's trying to ask. Either this is something.
So right now when you see we are processing on the edge computing, where when data target is detected, we put the time reference there and pushing the data on the cloud, and the cloud will run our data center will run the analytics server, but edge computing will do the preliminary AI solution. We are doing there also, and the large scale AI will done on the computing center, data center. So edge computing or IoT enabled device are definitely put in the sensor sites or satellite side. They will do some form of the analysis and push the data to the control center.
So Venkatesan, you want to add some more on this image computing aspects? Yes. Is there any similar questions to Dr. Venkatesan?
Check. My question is basically, as an operator out in the field and as a planner, okay, I want to optimize the patrolling of my ships and aircraft. One. Okay. So how are you with software or AI are going to help me do that? Though I know operational research, you have certain solutions available doing linear equations and what all, but using AI for any kind of a situation, if I need an optimization of the petrol, say I have about 50 units and I have to cover almost about 1,000 different areas and there are different requirements. So how would I optimize my petrol, the petrol of the units? And how would AI be helping me in my this day-to-day running, which is very important, day-to-day surveillance?
I can take this question. It starts from, let's leave the AI a little aside. It starts from the basic digital transformation. The technology is not doing anything additional than what the user is already doing. For example, whether it planning of operations, planning of the ships or the aircraft, whatever traditional things which is happening right from the annual flying task the headquarters would like to give the units, right down, it starts from there, then your day of operations comes. So that activities, the digital transformation, once it happens, there the optimization problems comes. You have a set of resources or the assets and you have the variables as far as the operational deployment requirements are concerned. When it comes to the aviation, your assets, your aircraft, your crew qualifications, ratings, all that becomes the variables. And this is an optimization problem.
Sir, you are not getting my question. What my question in plain terms is, this is my problem, I want to optimize the petrol. Can you give me a solution? Can you give me a solution? That is what I want to know. Yes or no?
Yeah,
I think
so I
depends
think
on various factors.
We are coming into that only, this whole the convergence on the opinion of emerging technologies, be it artificial intelligence or the machine learning. What we are talking about is for the same purpose. This optimization of the, let's say for a particular mission to be done in area so and so, and the assets are so and so, and what should be the optimal solution for you to execute. So that's the response strategy which we spoke about also. Yes, that is what we are all heading in. I do not know whether I did clarify or not, but this is what I could at best explain.
Can I just add just one small question related to what was asked just now? I'm here. I am B.S. Jaiswal. I am Joint Commissioner of Police in Delhi Police. So I'm also doing research on AI and ML and how to use AI ML in policing. So I have developed two algorithms for prediction of homicides, prediction of high volume crimes, and also how to make predictive deployment. So what I can infer from the question that, you know, if you have large amount of requirements, you have to maybe you have to manage thousands of assets, thousands of places, and you have limited resources. So you cannot either you do it randomly or based on your some kind of perception, some kind of insight which you develop over a period of time. But we can also do it algorithmically. We can analyze last 3 years data. We can find out the background level of incidents happening and what is the current trend, recent trend which is happening. And all these things can be learned algorithmically also. So there is an area called predictive analytics, and that has been done in crime prediction and predictive deployment. Same can be done in any kind of spatio-temporal events, right? So what I can infer that because we have to do maritime policing also. So I mean some kind of collection of data, and the data can be annotated also, like where all events have happened in past, and using machine learning, even deep learning, maybe very advanced algorithm like convolutional neural network, we can figure out very accurately which are the places which have high probability of events happening. And that is something which shifts every day. Every shift you have to retest on the algorithm with a new series of data which is coming in. So it's a kind of daily exercise which you have to do. The best output will come if you have very well curated features from the field itself, and also many other kind of features which may have some bearing on the events happening. So it's not only where all the events have happened, spatio-temporal data, but also many other kinds of data which may have some bearings. And I think the role of different agencies comes in the picture, and based on that we can do meaningful deep learning exercise, and that has been proven in many other fields, and it can be equally applied in maritime security. Thank you.
Thank you so much, sir. I think you provided important information on this, and think we can adapt to a maritime policing aspect also. Thank you very much. Is there any other question?
To his question.
Yes, I think Dr. Tessie is going to add on to this.
So land-based, the area, the data gets restricted, whereas in maritime, when you have assets, let's say we have 50 ships as he mentioned, the data collected, the boundary of threat for him is limitless. So that's where we have to have the data, the information what is collected with the new techniques, AI-based deep learning techniques. We have to have a clarity of the image and systems what we have with the area-wise. That has to be in the stored information, and if a single another object is entering into that space, now with the algorithmic and predictive technologies, we can bring it out, that it can give the signal that there is a new element has come, new image has come. So that way, lot of data analytics getting into the data fusion and analytics will improve our situations of with the help of artificial intelligence to detect. Thank you.
Sir, I would like to add something. Artificial intelligence will help you where to prioritize your task to optimize your operation. Depending on the threat set you have, if you have an oil vessel that is being hijacked and has been changed its course, your response time is different than if a warship comes into your maritime region. So your response time is going to be different. So these scenarios can be used with the artificial intelligence and machine learning in order to prioritize the task and ultimately give you recommendations on what you need to act on first based on your available assets. Just a small example.
But here I want to the artificial intelligence to provide the decision support automatically, but not remove the human in loops. He helped the human in a big way. The commander can always take a quick and fast decision. It's not replacing the commander. It is a tools which give the big bay post to take their OODA loop in very, very short form. This is ultimately thing, sir.
My apologies for interjecting the panel, sir. I'm sure a lot of the questions would be answered, but we have a young audience, and owing to paucity of time, we would like to invite at least one question from our bubbling audience. Although the roar of the engines would have truncated your curiosity, one question from our youngsters in the back. Yes, please.
Good afternoon. My name is Kirti and I'm from PS University. And my question is directed to Mr. Sanjeev Venkatesan. My question is, as someone with experience working with global defense organizations, can you please throw some light on how tech used in Indian defense compares globally?
She's saying how the tech of Indian defense, where does it stand globally? Is it right?
Yeah, that's correct.
Right.
That's a very that's a very, very good question, which I politically definitely avoid answering, because sir only in a previous speech he only mentioned IIT for research when I was a graduate of NIT, so I take offense to that. with respect to that he completely avoided NIT or IIT. But I think defense industry in India, if I understood your question, they're making great progress. I will tell you, in 2006, when I came here first on Def Expo, I was with a very experienced air defender, retired colonel from US Army. And he was walking around with me, and he said, Sanjeev, and I was very new to air defense. He said, Sanjeev, when you see these systems, and at that time Akash was displayed as one of the showcase. He says, what's the difference between the US system and Indian system? So I said, I guess they both do air defense. He says, the key to US defense versus Indian defense is size and capability. If you look at, we in the United States have mastered the art of miniaturization. And that gives mobility, that gives portability, that gives range and effectivity of the same system that is maybe 3 times the size here. India is in a right path with respect to what they're doing from an investment and industrialization. It is going to take some time to reach there. I'll give you another story. Mr. Ratan Tata visited Raytheon facility on a Patriot manufacturing facility. So he was given a very detailed tour of it. And at the IC manufacturing, he was given a part to hold in his hand. And the gentleman who was presenting said, please don't sneeze, sir. You have 10,000 parts in your hand, which is the size of a sand particle. And these parts are placed on a board without any part numbers, and it uses machines to place these ICs in a board. So that's the level of miniaturization the US company has reached. That takes a lot of investment. Obviously, you know the defense budget. Our defense budget is $700 million compared to what India is investing and trying their best to improve, and they're doing a great deal with that. So I think eventually they will reach where such a country like United States has reached, but they're not very far away. Thank you.
Thank you so much.
I hope that answered your question. I think we can take one last question from the younger audience.
Good afternoon. My name is Sankar Devanand and I'm a student from PS University. My question is directed towards Inspector General Donnie Michael. I had recently seen a video on social media in which a narco submarine was caught by a US Coast Guard. Since these submarines are usually the size of whales and can be used to carry weapons for terrorist attacks like 2611, I also feel it will be really hard to be detected by sonar or sound surveillance system. How can this be handled, sir?
Question to me?
Yes.
I don't know. I myself can't recollect making a video. So anyway, I try to answer. Right. Okay. Firstly, I want to say about the Coast Guard. The Coast Guard operates its vessels on the surface, and we have air assets, so mostly used for surveillance and for response operations. So if you want to ask particular questions about underwater domain awareness, I have to be frank, I have to say that I don't have much knowledge on that. But according to the open source...
Sir, if you allow, I am aware about this video. I have seen this, what he's talking about. And yes,
yes,
it is
you can go ahead.
It is used, narco submarine, I am aware. But you have to understand, when we draw our threat matrix, we have to, like, if we have to catch somebody, we have to choose the vulnerable points. Ocean is a very vast thing. You cannot, there is a concept of sea denial and sea control. And they require huge amount of resources. You have to understand, if this narcotic submarine also moves, it moves from one end to another end. So there are ways and means by which it can be detected in the shallow waters. As ma'am also mentioned about the periscopic depth detector.
Thank you, sir.
Very heartening to see the younger generation posing questions of this depth. I'm sure that the gathering, especially our college friends, would be bubbling with the curiosity. And I hope that at least some of the questions have been answered. But owing to time restrictions, we shall be now moving forward to the felicitation ceremony.
I would like to request Additional Director General K.R. Suresh, President Tatrakshak Medal, Coast Guard Commander Western Seaboard, to kindly present token of remembrance to our speakers and panelists.
We would now be calling upon the panelists and speakers to receive the same. Inspector General Donnie Michael, Tatrakshak Medal, Deputy Director General, Coast Guard Selection Board.
Mr. Padma Kumar, Managing Director, Engrave Aviation Services and Systems.
Deputy Inspector General Atul Agarwal, Commanding Officer, Coast Guard Air Enclave, Kochi.
Mr. Sanjeev Venkateshan, Global Director, Capture and Capabilities, Raytheon Missiles and Defense.
Mr. Anup Kumar Rai, Chief Scientist, Bharat Electronics Limited.
Commandant A.R. Kalingal, Flight Commander, Dornier Training Flight.
Mr. Kiran P. Kulkarni, Director R&D, Haribon Aeronautics Private Limited.
Dr. Tessie Thomas, Director General, Aeronautical Systems, DRDO.
Now, I would request Dr. Tessie Thomas to kindly present a token of remembrance to Additional Director General K.R. Suresh, Coast Guard Commander, Western Seaboard. I believe Dr. S.K. Venkatesh had to leave us due to an exigency. We would be handing over the token from our side very soon to him. Thank you, sir and ma'am. Now I would like to request Commandant Parthu Mukherjee, Officer in Charge, Coast Guard Project Overseeing Team, and the head of the organizing team of this event for delivering the vote of thanks.
Distinguished dignitaries from Indian Coast Guard, leading industry representatives and delegates present today in this August gathering. On behalf of the Indian Coast Guard, I would like to extend a heartfelt vote of thanks for your presence and participation in today's seminar. Your presence and active participation have made this event a huge success. It was a great pleasure to have such an engaged and knowledgeable audience. We are grateful for the insightful questions and the lively discussions that just you witnessed that had added tremendous value to our seminar. I would like to express our gratitude to Indian Coast Guard Headquarters for giving us this opportunity, and we are so grateful to our chief guest who gave us valuable guidance and has always been appreciative of our small efforts. Sir, we are honored to have you amongst us today. I also extend sincere thanks to our flag officers and other senior officers who have honored us with their gracious presence despite their extremely busy schedules. I thank you, our distinguished speakers and panelists who brought their expertise and shared their wisdom with us, making this seminar truly informative and enlightening. Our sincere thanks goes to all those who have contributed to this event and has made this seminar a grand success. We hope that this seminar has added some valuable and inspiring notes, and we will all benefit and take away some valid points and new ideas, perspectives that will enhance our professional growth. I extend a special thanks to the young minds sitting behind of this country, representing various renowned institutions who took the initiative, took the pain to travel all the way here in the early morning and participate in the seminar to understand the nuances of maritime surveillance. Hope today's seminar has given you an insight into the unstinted efforts and synergized teamwork that we in Coast Guard do, that remains unseen and unheard most of the time, but makes our maritime boundaries safer with each passing day, thereby safeguarding our national interests. Finally, I would like to acknowledge the hard work and dedication of my organizing team. This team is very small, a tiny size, but you have worked relentlessly behind the scene day and night to meet the deadlines leading to this seminar. I thank you for your commitment and making this a memorable experience for me and all of us. A small applaud for them. I take this opportunity to thank Aero India team, sponsors, and our partners from press and media who are covering our event and streaming it live. Ladies and gentlemen, once again I thank you for your time and support, and we shall look forward to see you in our future endeavors. Do remember the motto of Indian Coast Guard, Vayam Rakshamaha, we protect. Thank you, and Jai Hind.
Thank you, sir. I request our distinguished speakers, panelists, and flag officers to kindly join the stage for a group photography. Requesting the organizing team for a group photography, please join the stage.
Once again, we would like to extend a heartfelt thanks to the audience for their undivided attention and involvement in the proceedings. The spectacular air show awaits you outside, but before you go, please do not forget to collect the thoughtfully curated mementos as a token of remembrance and thanks from our side. Thank you to all in the audience. Jai Hind and Vayam Raksham.